The drive unit of the compressor supplies the power for compression. Rotary motion from the power source is converted to reciprocating motion by the crankshaft, connecting rod, and crosshead. Let's take a moment and look a little closer at how each of these parts functions. The crosshead joins the connecting rod and piston rod. Passing through the distance piece, the piston rod drives the piston. The crosshead allows the piston rod to move only laterally, yet allows the connecting rod to have rotary motion. A lock nut secures the piston rod to the crosshead. The connecting rod is attached to the crosshead with the crosshead pin. The crosshead travels horizontally and must have limited vertical variation. This confinement is maintained by the flat or circularly bored crosshead guides. Inside the guides, the crosshead shoes maintain the vertical position of the crosshead. While the shoes are replaceable and adjustable, shims on both of the shoes provide additional adjustment. Both ends of the connecting rod are equipped with heavy-duty sleeve bearings. These bearings are adjusted using the adjusting wedge and adjusting bolts. The sleeve bearings may be made of babbitt, bronze, or aluminum. Inside the sleeve bearings, the crosshead pin and crank pin are separated from the bearings by a film of oil. This is crankcase oil supplied under pressure through holes in the bearing surface. The power to operate the compression unit is usually supplied by either electric motors or engines. The most typical, however, are combustion-type engines. In these, power pistons are connected by connecting rods to the crankshaft. In addition, the crosshead is connected to the crankshaft by a connecting rod. Thus, rotation caused by the power pistons is translated by the crankshaft, connecting rod, and crosshead into reciprocating motion, which powers the compression unit. Now, just as lubrication promotes smooth compression unit operation, lubrication of the drive unit is equally important. However, lubrication of the drive unit will be covered in a later module. Often a compressor has more than one compression unit on the same frame. In these arrangements, each compressor piston is powered through the same crankshaft. One example of a shared crankshaft is a balance-opposed compressor, like this one. The cranks are arranged so that the motion of one piston is balanced by the motion of the opposite piston. Balance-opposed compressors are often externally driven. The compressor crankshaft is coupled to an engine or electric motor. Others may be engine or motor driven through a V-belt drive or motor, or turbine driven through speed-reducing gears.